So this video is going to go over tokenization. If you want to understand how LLMs work from a first principles point of view, this is a key concept, right? For NLP as a whole. Every single time you click enter on ChatGPT, your words are being converted into tokens. And so this video is going to explain what that is, why we use it, and go into a little bit of the nitty gritty so that you understand from a holistic point of view of what is going on inside an LLM. So the first thing you need to understand is that researchers had a problem. And that problem was our English language, like the way we're speaking, natural language in NLP, natural language processing, has 26 characters, right? We have A, B, C, D, and like I'm assuming it's English here. There's 26 characters here. And it's a problem because computers only understand 0 and 1, right? It's only binary. And even if you go to quantum, it's 0, 1, and 0 or 1. So how do I find a way to represent 26 characters? I can't have 26 on and off switches, right? Like it's not possible. It's only 0 or 1. So the bigger problem here is how do I represent language, which is something that we understand, into something a computer can understand? Because if a computer understands language, which is what LLMs actually are, then now we can start doing some cool stuff like generating text, understanding text, classifying text, all that stuff. That is the problems that researchers faced. And the solution to that thing was put very simply. If I say my name is Jeeth, horrible handwriting, I'm just going to represent an ID for every single word, which is a very brute force approach. At least that's what I thought the first time I heard about this. But this is 0, 1, 2, 3. And the cool part now is that because like my can be represented in a computer, but 0 can, right? So can 1, so can 2, and so can 3. Like it's bringing it down to its most basic level. It's 0, 0, 1, 1, 0, 1, 1. And this is something we can store in memory. And because it's something that we can store in memory, now we can actually start doing stuff with it inside a computer, right? So obviously it doesn't stop there. This is tokenization, right? Like that's it. Hey guys, real quick, if you're interested in using AI for your business, my company ApplyGPT helps you with just that. I'm gonna put my link down below and enjoy the video. It's a process of converting a word into a number. That is what a token is. And to kind of drive this point home here, if I have the same sentence, I can just do the same one. My name is Jeeth. If you look over, and this is the OpenAI Tokenizer. So like Tokenizer is the process of tokenizing a sentence. My name is Jeeth. Notice how this is like highlighted in different things. These are just numbers if you look at the token IDs. That's the same as this. Like every time I see I'm going to represent that with 0, associate that with 0. In this vocabulary here, my name is Jeeth is the full vocabulary size. Like that's the only thing that I know in this hypothetical example. Obviously, if we want to actually use language, we need the computer to understand every single possible type of word there is, right? So that is what like the OpenAI Tokenizer does. Like this uses the byte pair encoding system. Anyway, the main point is my is this number right here. Name is this number right here. Is this number. And an interesting thing here is Jeeth is broken down into two tokens, excuse me. And the reason for that is because this particular byte pair encoding mechanism here determines that JE pops up so often in language. A better example of that would be like something like unnoticed versus, and there's two N's here, versus unfazed. This is a bit of like I guess a technical thing, but just think about it like logically, right? If I have to represent these things with two different words, I'm gonna have to figure out a way to get on everything, like unfazed, unchartered, unamused, like every single word of I need to have a separate one. So it's just much easier if I just break this down into two tokens here. So that is one thing, and like after that it's a regular word. So now in this way I can represent noticed and unnoticed by having these two tokens here, right? You see how that's just like an optimization here. That's why JE, that's why people say that just because it's one word doesn't mean it's one token, because if I do something like unnoticed, notice how on is his own little thing here. So, and then same thing for the period. Or the period also means something. Like just because you have a period, that doesn't mean a computer understands it. It needs to be a number. So like in this case, it's gonna be like 13, right? That's gonna be the number it represents. So that is what tokenization is. But I want to take this a step further so that you understand. You're probably at this point like, okay, these are numbers, but that doesn't mean anything to me. It doesn't mean anything to a computer. And you're correct about that. So tying this into how LLMs work, how do we go from this right here to this? That's what the next final part of this video is going to be. So I just want to make sure I'm inside. The way this actually works is, assuming that I have this right here, I'm just going to represent it with a matrix here. So to not confuse you, this is the same thing. My name is Jeeth. and like just like this part right here, right? Every single word and every single, like, now you know every single token is going to be associated with a value here. So it's going to be 0, 1, 2, 3. And so we know that large language models are deep learning models. Like, let me just draw this out. We just have a bunch of neurons, which is just a bunch of numbers that when evaluated together give me my end result, right? If you don't know that, that's kind of a simplified way of thinking about neural networks, right? Like, these neurons here are just a bunch of numbers, and what happens is these are being multiplied across to give you an output. And so I guess this is kind of cool, but these tokens by themselves don't mean anything. Like, we as humans decided those numbers. Like, so during the training process of an LLM, what's actually happening is on one side we're gonna have this matrix right here, which is 1, 0, 0, 0, and what that's saying is just give me the word my. Like, that's it. That's why there's a 1 over here. And on the other side we're gonna have 0, 1, 0, 0, and that's gonna be just give me the word name. So you know how people talk about like how LLMs are an autocorrect machine? This is what that is. If I see my, no matter what, I want the next word to be name. The way that's actually done is that you have two matrices here. One is 1, 0, 0, 0. The other side is 0, 1, 0, 0. And we're going to try to find a way, a path, so that no matter what happens, whenever I put this into my system here, I get this out. So the actual training process is finding a way, finding a combination of numbers so that when I put this one here, I'm going to multiply a bunch of numbers together. I'm going to get this one here, right? And 0, 0 here. These are all actually probabilities. Like, this is 100% 0, 0, 0, 0. In practice, it's going to be more like 0.1, 0.8, 0.1, 0.000 something. Like, that doesn't add up to 1, but you get the idea here, right? So like, when I evaluate this thing from 100%, it's going to give me a new matrix, something like this, and the highest word is going to be chosen. So in this case, because this probability here, 80% is the highest, I'm going to pick this one right here. The 80% contributes to this one over here, and what does this one represent? We already know. It means name. So that is how the autocorrect is happening. If I put in my, I get name. That is how this whole thing kind of ties back together, right? And like, that is the meaning part. Like, that's the semantic. Semantic just means meaning. That is how you assign meaning to numbers. And so at this point, I hope it's pretty clear, right? Because we assigned it to IDs and because we're doing a bunch of matrix multiplication, we already know that we can do multiplication using computers, just using zeros and ones. So like that's how you convert language into numbers. And because you can convert it into numbers, we know that we can actually do fun stuff with it, like multiplication. Because we can do multiplication, in this case, we're representing that by the next word here. Like, if I use my and I do a bunch of matrix multiplication, I get name back out. I actually get a 1 back out or 0.8 back out. But because we know that the 0.8 is associated with 1, we know that that is name. So that's how this whole thing kind of ties together. Yes, it is actually a bit of a black box. If you're a little confused, like, how do the numbers actually work? The reality is nobody really knows. Like, and that's just me being honest with you. Like, nobody knows like why in these, and this is like a million billion parameters. Like, this is the parameter part here. Nobody knows like exactly how it's doing it. It just knows that it does it. And it's a bit of like a brute force approach. Like, I'm going to manually adjust every single billion value number so that I get the right output. And I mean, it's working, right? We see ChatGPT and it's giving pretty good results. So I want to tie this back off. I know I said I'm going to end it here. What I want you guys to realize is that every time you click enter into ChatGPT, like if I say, what is your name? ChatGPT, we know this now. ChatGPT is not seeing what is your name. It is seeing a matrix. In this case, like the previous example, it's going to be 1, 2, 3. And then that's going to do a bunch of computation, like a bunch of matrix multiplication across the neural network, right? That's really what this is. And it's going to give a new matrix back out, like 5, 10, 12, 3. And that represents like I am ChatGPT, right? That's how this whole thing kind of comes back together. The whole point of tokenization is it converts words into numbers. So that's going to be it for this video. If you guys have any questions, just comment down below. And if you enjoyed this, like, subscribe, all that good stuff. Thank you guys so much for watching. Bye-bye.